Hey, let me do this one and stop. Then I'll complete the remaining because it's only one that we have left here. Higher order derivative. Higher order derivative. 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 So don't mind my handwriting. Don't have a good handwriting. I'm just trying to find it myself. I have my bosses in the house. So higher order means when you are differentiating the functions more than one times. The polynomial, in some cases they can call it polynomial functions. Maybe you have to find the y dx or the square y over dx square or the cube y over dx cube, the 4y over dx square, depending on what you are asked to find. And they can use many ways of representing it. If I have the y dx, this is what we call f prime of x. I've already explained this one under the first principle, and this is nothing but y prime. So this one we call it a first derivative. That means I'm only differentiating how many times? One times. So now, if I have the square y over the x square, this is nothing but f prime prime of x. This is y prime prime. That means I'm under the second derivative. You see how it's going? Very sweet, Abby. So that means if I'm going for third derivative, can you guess how I will put that? Yeah, it's going to be third, 3. The cube y over the x cubes. Just be counting the prime here. That means that we have f prime prime of x, y prime prime. Then this is third derivative. So like that. So it depends on what you're asked to find. But the thing is, if you don't have the first derivative, we cannot have the second derivative. If you don't have the second derivative, we cannot obtain the third derivative. We use the after getting the first derivative, then second derivative, third derivative. Like for example, maybe they said y is equal to x5, and they said find, maybe they say I should find the 4y over the x4. That means I'm looking for the fourth derivative. So I need to find the fourth derivative first, second derivative, third, until I reach fourth derivative. So now, here we have the y dx, the differential of x5, now we are going to have 5x4. This is fourth derivative, right? The result I got is what I'm going to differentiate again. That is going to be the square y over the x square. Differential of this again, now we have 20x cubed. You get that? Now, again, third derivative, the cube y over the x cube is going to be differential of this one again, now we have 60x squared. You can see the logic is without the fourth derivative, we cannot obtain the second derivative. Without the second derivative, we cannot obtain the third derivative. We are using one to get the other one. So now, in what we are going now, the 4y over the x4 is equal to differential of this. I'll just have 120x. You can see the way we do that. So now let's see a question from okay, you want to give me questions? Yeah, you can just help us to write it out so that we have a boss here. They want to give us a problem. Hope it's going to be higher order. Which derivative are we to find? So now we have to find the fourth derivative. So you have to thank my boss for creating a portion for us. So now we have y is equal to cos x plus x e to the power of x plus 4x4, and we have to find the fourth derivative. So now, as I told you earlier, under derivative, get the first one. After getting the first derivative, go for the second. After second, go for the third and the fourth. So it's a lovely question. So let's see how we are going to approach that. We said y is equal to cos x plus x e to the power of x plus 4x4 x to the power of 4. So now let's only find the fourth derivative of this. So here we have the y dx. I told you earlier, when we have differential of sine x is cos x, and when we have differential of cos x is what? Yeah, minus sine. So here we have minus sine x. But now you can see here we have two functions at a time, meaning we have x and we have exponential function. So how do you I told you that one too as well. In case if you miss our product rule method, how we normally differentiate two functions, Differentiate the first one, keep the other one as a constant. Differentiate the second one too, and keep the first one as a constant. So now, differential of x, we have 1. I keep this as a constant. Plus, so I keep x now as a constant. The differential of e raised to the power of x, what are we going to have? Yeah, we are going to have. You remember how we normally do the exponential? I told you that one that if you are dealing with exponential, you will treat the powers. Whatever you have for the power, multiply it by the problem itself. Like this one, the y ds of this is going to be, differential of x, we are going to have 1, then times e raised to the power of x. And if I have 1 times 6, of course, we are going to have e raised to the power of x. Then plus differential of 4x4. What are we going to have? Yeah, we're going to have 16x cubed. So now, let's write this one properly. So that means here I can have this one to be dy dx is equal to minus sine x plus e raised to the power of x plus x e raised to the power of x plus 16x cubed. So now the next step is to find it again, because we are going to fourth. So second derivative, that's the square y over the x squared. So differential of sine x, is going to be cos x, but you can see we have a negative here, that minus cos x. The same thing for this. I will still have e raised to the power of x, just like the way we treated this one. The way we do it, what we get is we differentiate this one, keep this as a constant, the other one too, and keep the second one as a constant. So I have e raised to the power of x plus x e raised to the power of x. Then now the one we have here, differential of this, we are going to have 48x squared. So again, I'll still do it again. So, but if you know that I can add these together because they are the same. If I add that one together, that means I can have the square y over the x squared is equal to minus cos x. This plus this, that's just like simple additions. I have 2 e raised to the power of x plus x e raised to the power of x, then plus 48x squared. So now we are going to fourth. We are still under the second derivative. You still continue until you reach your destination. Now let's find the third derivative now. That is the cube y over the x cube is equal to minus. You see, division of course is nothing but what? Minus sine. So we have minus sine x plus this one twisted the same thing. Division of this, and we have 2 e raised to the power. Don't forget the way we treated this. If you remember this one, right? For the first method, this is the e raised to the power of x plus x e raised to the power of x. Now this one, division of 48x squared, that's going to be 96x. So from here we can see this is minus, this is minus. So minus times minus, we are going to have plus. We have the cube y over the x cube is equal to minus times minus, we have plus. I have sine x plus, I can add this one together, 3 e raised to the power of x plus x e raised to the power of x plus 96x. So I'm just in third derivative now. So we have to find the fourth derivative. So meaning I'll see how to differentiate this, my result, one more time. So that means here we have the 4y over the x4 is equal to differential of sine x. What are we going to have? Yeah, we are going to have cos x. Differential of this, I will still have the same result, 3 e to the power of x. Then differential of x, just like the way we had treated it earlier, keep one as a constant, differentiate the other one. So we have e to the power of x plus x e to the power of x, then plus differential of 96x. What are we going to have? Yeah, we are going to have 96. So let's see if you can see add the values together. Of course, we can add this together. So we have the 4y over the x4 is equal to cos x plus this, and we have 4 e raised to the power of x, then plus x e raised to the power of x plus 96. That's our fourth derivative. Even if you have to find the fifth derivative, that means you still take your results and see differentiate it again. So that's all we have for higher order derivative. So